Hello, in this video I'm going to cover the malonic ester synthesis. And the malonic ester synthesis is a way we can take diethyl malonate or malonic ester, and through a series of steps we can make an alpha alkylated carboxylic acid. And we can either put on one alkyl group or we can put on two alkyl groups. These alkyl groups can even be different, and we can even make a ring by having like a dihalogenated alkyl group, so like bromines on either side of the alkyl group or something like that. And so I'm going to give you an example, and then I'm going to kind of go step by step through the process, but I'm not going to give you a full mechanism. You're not going to see a whole lot of curved arrows in this video because it would just be too long. And then if I have time, I'll give you a couple more examples. All right. So I'm going to start with an example with a monoalkylation. So I can have a first step where I have sodium ethoxide, and then let's make this a simple chain, maybe CH2, CH3. Okay, and then we're going to have a second set of conditions after that where we have H3O plus, H2O, and heat. Okay, and then what that is ultimately going to give us is this molecule. All right, and so a couple of things you can see have happened here. One, we've kind of lost this whole portion of the molecule. Secondly, this ethyl ester has been hydrolyzed to the carboxylic acid, and thirdly, to this middle carbon, we've added this ethyl group. Okay, so let's go over the steps of how that happens, because that's a lot of things going on there. All right, so I'm going to break it down for you. Alright, so we're going to start up here with our malonic ester. And it's called the malonic ester synthesis not because we're making malonic ester, but because we're starting with malonic ester. Okay? The first thing that happens is the ethoxide comes along and we pull off that hydrogen, and we're going to form the enolate. Oops, okay. So, and this is a pretty well resonance stabilized enolate. Okay, I could draw two other resonance forms for that. All right, and then what's going to happen next, so that's just a proton transfer, that's pretty simple. And then actually the second step is pretty simple as well. All right, this is going to be an SN2 reaction where our nucleophile is that enolate, and this is the alkylation part. Okay, so we make this alpha alkylated diester. Now at this point I could do a couple different things. So I could add in sodium ethoxide and another alkyl halide, and I could do a second alkylation where I replace this hydrogen with another alkyl group, so that would just be repeating these two steps for a second alkylation. Or what I'm going to do at this point is I'm going to do an acid catalyzed hydrolysis. So H3O plus and water. Okay, so this is acid catalyzed ester hydrolysis. So this is the opposite of a Fischer esterification, okay? And this, I think we talked about this or something similar to it in a previous lecture or previously. And so I'm not going to go through the whole mechanism. I think it's like 6 steps. Don't have time for that in the video. But it's an acid catalyzed hydrolysis. Okay, so both of those esters, those ethyl esters, get turned into carboxylic acids. So now we have a dicarboxylic acid, and I guess we make 2 molecules of ethanol in the process. Okay, so we're breaking the ester down to the carboxylic acid and the alcohols. All right, and then I'm going to redraw one of my carboxylic acids, because now we're going to do something that we haven't seen yet before. So let me erase some of this. So I'm going to rotate this carbon-carbon bond. Actually, I'm going to rotate this carbon-carbon bond. So I'm going to kind of signify that with this squiggly line here. And try to make sure I have some room here to do this. Okay. Didn't give myself room. Okay. Okay, so you can see how this carboxylic acid is still there. I've just rotated 180 degrees around that CC bond. Okay, this is going to stay the same. And then what I'm going to do is, you can see I have something that looks like a 6-membered ring. It's just missing a bond. And what's going to happen here, I just have to be careful to go the right direction with this. Okay, so what we're going to do is we're going to form a pi bond there. We're going to break this OH bond, and we're going to form an OH bond here. And then this pi bond is going to become a pi bond there. And what that's going to do is we're going to lose CO2. So it's called a decarboxylation, because we're losing CO2. And we're making this. Okay, and that looks kind of like an enol, because it is enol. All right, and you might remember that either under acidic or basic conditions, we can tautomerize an enol over 2 proton transfers to the keto form. Okay, so we're going to have an acid catalyzed tautomerization. And that will ultimately get us to here. All right, and there it is, our alpha alkylated carboxylic acid. Okay. So there's a lot of individual elementary mechanistic steps, but we can kind of summarize the whole process as a base catalyzed or base promoted, I don't know, basic conditions, alpha alkylation, followed by an acid catalyzed hydrolysis of a diester, followed by decarboxylation, and then acid catalyzed tautomerization. Okay, so let me give you a couple more examples of how we could use this malonic ester synthesis. Again, these are always starting with malonic ester. Okay. So I could do sodium methoxide and, okay, there's a 3-carbon alkyl halide. And then I could do a second step that's sodium methoxide and maybe a 2-carbon alkyl halide. And then we can have a third step that was H3O plus, H2O, and heat. All right. And then ultimately, the product's going to be a carboxylic acid. We've got a hydrogen here. And then we put on a propyl group and an ethyl group. Okay? So that's a kind of a, we can do a dialkylation. We can use different alkyl groups if we want to. And then we can also make a ring here. And I think I have time enough to show you how we might make a ring. Again, we're starting with diethyl malonate. We use sodium methoxide. Remember, we always want to match our base to the type of ester we have. Okay, and let's say we had 1, 2, 3, 4, 5. Okay, remember that. 1, 2, 3, 4. Oops. I wanted 5 carbons. All right, 5. And then we could second step, H3O plus, H2O, and heat. Okay. And then what our product would be. Okay, would be this. So now we've got a 6-membered ring, a cyclic carboxylic acid. 2, 3, 4, 5. Looks something like that. And there may be, I'm trying to think if sodium methoxide is added twice. Ah, yes, okay. So I should put that in here. Okay. So this is step 1. We're going to have what I'm going to call a 1B step, where there's sodium methoxide again. All right, so you have to have sodium methoxide for each alkylation. All right. Great, so that's going to conclude this lecture on the malonic ester synthesis. Yeah, thanks for watching.